So let us start this lecture number 4, which is the beginning of a sequence of 3 lectures which all deal with natural language processing data. And in this lecture, we're gonna see a small introduction to text corpora and to ways of accessing text corpora with Python, and in particular with the NLTK toolkit. So we start out with a brief definition of text corpus. A text corpus is a large body or collection of text. There are 2 important ingredients in this definition. The first one is text. So we are dealing with textual material instead of, let's say, images. Secondly, a text corpus is usually considered only a corpus if it is like big enough. So it should be a large collection of individual text, rather than a very small text snippet. So text corpora are typically designed with specific goals in mind. So, for example, we want to analyze or we want to collect the literature from the ancient classics up to the modernity, or we want to collect newspaper texts, all written in the present time period, but across different areas within Germany, let's say. Usually, the editor of a text corpus or the editors of text corpora take care that their material has been balanced in some way, let's say across different genres. So if you are publishing literature, you might want to take into account that you include both female and male authors, that you take literature from all time periods and from all different literary styles, for example. Examples of text corpora are given here. So there are 3 text corpora examples, 2 of which we will go into much more detail in the following slides. The first example is the US presidential inaugural addresses. So each president of the United States gives an inaugural speech in the year where he or she is elected, and these inaugural speeches have been collected into one corpus of presidential inaugural addresses. A second example is the Gutenberg corpus, which is a corpus of literature that is including both prose and, let's say, poetry across multiple centuries, across multiple authors, and also across different languages. So this is available for German, English, Latin, etc., etc. The third example that is listed here, but which we will not discuss in the rest of the lecture, is the World Wide Web, which can also be considered a corpus. It is a different corpus from the other 2, in that, well, partly from the Gutenberg corpus, but partly the Gutenberg corpus is similar in a sense, but the World Wide Web really is a initiative that is not, well, it has not only a few editors, like 1, 2, or 3 editors, or a couple of them, but it's really a collective intelligence of all of humanity. And it is also not constructed in a top-down manner, such that some people are thinking now we should collect, we should create a corpus that contains a lot of different textual material across aspects that humans find interesting, but it's really constructed bottom up. So there are individual people with their interests. So, for example, they want to buy cars, or they want to find a partner, and in these bottom up initiatives, they are creating texts, and this text later constitutes the World Wide Web. And from an NLP perspective, this World Wide Web may also be considered one huge gigantic corpus.
How about doing
how about processing Corpora in NLTK? So let's do this a little bit interactively, because I would lie if I would say that I know all of those things that we see in the following slides. So the best way to explore this, and that's hopefully a lesson for you, is just like empirically, we check what's out there practically by going through examples, and then you'll see, you'll understand this uh, better in more depth and from a practical perspective. So I make a small shell up here that allows us to do this thing interactively. So in the Linux shell, I have the Gutenberg corpus, and now we do import NLTK. So I've already done this, so it's already there. Then we go to NLTK corpus. So you see that this is an object. Then we go to Gutenberg. We type in Gutenberg, another object, and then we type file IDs. And what we get here is well, we get a collection. In this case, it is only like of a few texts. Like, how many are these? So this is only 18 texts, and the texts are like Austen is like Jane Austen is a popular English writer from the 19th century, I guess. And she has written different texts like Persuasion. So they are abbreviated here by Emma, Persuasion, Sense, etc., etc. And she has written other texts, but they are not in the collection of the Gutenberg corpus, or not in this subsection that we are dealing with here. And there's also Shakespeare, etc. So there are different writers in the corpus, and they are listed by these file IDs. Now I only have 18 texts here, and that's maybe because I downloaded a smaller version of the Gutenberg corpus in NLTK. But anyway, we have just 18 texts here. Now, how do we assess a single text? So what we can do is we type in the method words here, and then we list a specific text that we have in mind, such as Austen Emma txt. So this was the first text here. And then you see what it's doing for us. It's listing all the words. So it's giving a list. So we can type what kind of object this is. So, okay, it's like a reader or something, but it presents it to us in list form, and it gives the individual words that are in this first text of the Gutenberg corpus. And I think now what we could do is probably can use it like a list. So we can say, okay, I want to have the second word, the third word, etc. And we can, of course, also we can store all of that in a variable that we call Emma, and then we check how many words are there. And it's like, how many words are these? It's like almost 200,000 words, right? Something a little bit below 200,000 words. So how do we import modules? You have just seen it. The notation that I've used is like, I've typed in import, and then the module you have to type something like NLTK, right? So that's the way you do it in Python. And yeah, you do it exactly as we've shown. Then the thing is that you cannot only you can import a module and then a submodule. You can continue how many submodules there are, or you can alternatively also use this notation from module import submodule, right? So this is an alternative, and then you have this submodule given here, and then you can apply all the methods available for the submodule, such as file IDs, to the name that you have selected here, right? And then this is sometimes more convenient instead of dealing with this very long text sequence, text string here, right? Okay, so what we can now let's do something with our with, for example, with all the individual files in the Gutenberg corpus, so we could iterate over all the files. So what is the file ID doing here? That's just a name that we give. So that's an iterator name. We could also name this totally different. We could call this file ID 2, file ID 3, or whatever we want. We could also call this Pete. We could also say for Pete in Gutenberg file IDs. So that's iterating over all the individual texts in the corpus. And then what we do is here we can count the number of characters in each text, the number of words, the number of sentences, and we can also count the vocabulary size. How do we do this? We would go over all the words in each specific file, so we have all the words in one specific file. Then in this case here, they decide to lowercase the words, so that if a word is lower or uppercase doesn't matter, so that's case insensitive. And then they say, okay, let's make a set out of that. So if a word occurs multiple times, we count it just as one time, and then we count all of the different words that occur in each specific file in the corpus. Okay, and just like for the sake of illustration, uh, let's again do a little bit of coding, or like let's repeat this experiment here that we've shown here. So what we do is from NLT corpus import Gutenberg. So this is what's given in the slide. Now let's make this a little bit shorter, Gutenberg. So we abbreviate this. So I use the notation S GTB here, and then I can say so. And let's say our text is like Austin Emma. So we put this into a string variable, and then we type GDB Austin Emma. Okay, did we make some mistake here? Yeah, so we have to type what we want. So we can say the raw text. So you see this is the raw text, just as a long text string. We can also say we want to get the words, and that's what we've seen before. So we get the words, and we can say let's get the sentences. Okay, here that's a typo. So we get the sentences. So now what we get is what you see here is it's like a list of sentences. So this is the so this is the first sentence, the second sentence, etc. So we get all the sentences. And then the other thing that we had was the counting of the vocabulary. So I'm skipping this. I'm skipping this for now. And instead, let's continue in the slides. So let us do some corpus statistics. First we count for each file in our corpus. We count the number of characters, the number of words, the number of sentences, and the vocabulary size. And then we print out the statistics here. So what we do is we print the number of chars divided by the number of words, the number of words by the number of sentences, and the number of sentences divided by the size of the vocabulary, and also we print out the file ID. So what do these numbers give us? So what is the interpretation of this? The number of chars divided by the number of words, that means how many characters does each word have in this specific file ID, in this specific file on average. And the second variable gives how many words does each sentence have on average, right? If you have 1,000 sentences and you have 10,000 words, then it means that each sentence has on average 10 words, right? And the last variable gives the number of words divided by the by the size of vocabulary. So this gives how often does each word in the vocabulary appear in the text on average. So if you have 10,000 words and the vocabulary size is 100, so then each word occurs 100 times, but this is just the average number, right? So the individual frequencies may vary quite a bit, but if we check for the average, that is what is the number is giving us. Now we also have this double symbol here. What is that? So that looks really strange, and maybe we do not know that from other programming languages. So what we can do is, and that's also what I recommend to you. You go to Google. You check what you check in what you're looking for. So we're interested in Python double division operator because that's a double division operator. And then we go, for example, to Stack Overflow, and we check here what are they saying. And they're telling us that in Python 3, because the normal operator is always giving a floating point number, so it's doing exact division. From Python 2, we are known that like if we do the division, um, um, for example, between two integers, we'll get an integer out. So if we want to have an integer, so that's rounding, that's doing rounding for us, um, then um, then we can use this double division to get the same functionality in Python 3 that we had in Python 2. So of course, all these numbers here would be floats. So because in average we have, for example, 25 million characters and 7,763 sentences. So if we divide that, we get a real number, not an integer. But for sake of like illustration and not having all those decimal points, we opt here to go for a more concise presentation that leaves out that just gives us the rounded numbers. Okay, we can also work with the sentences. What we would do here is we go to Gutenberg sentences, let's say for Shakespeare Macbeth. We check all the sentences. We get a specific sentence, let's say sentence number 1116, and then we can do all kinds of statistics that we're interested here in. For example, here we take a list, so we do this this concise Python notation again to iterate over all the sentences in Macbeth, to take their length and then take the maximum. This is taking the maximum of this list here, so we get the longest sentence, right? And if we check what is Macbeth sentence 1116, well, it's this one here. What's its length? We don't know what its length is, but what we can do is we can quickly calculate this ourselves. Let me just type this. So we type Gutenberg sentences, right? Is that sentences? No, it's sense. So we do Gutenberg sense, and we go to Shakespeare Macbeth txt, and we go to sentence number 1116. So this is exactly the sentence. And we check how many words are in this sentence, how many tokens. It's 14 tokens. Okay, cool. So we've done a little bit of cool processing of our corpora. So, and this was the Gutenberg corpus. Now let's check other corpora. We can take web and chat text. So we import from the NLTK, we import web text. We can also, again, iterate over all the individual texts in the corpus. And what we do here is we get an illustration of how the corpus looks like. So we type the individual text. So this is Firefox, Grail, TXT, Overheard, Pirates, TXT. So these are different texts from the web. We get the raw text for each of the
for each of our individual texts. So we get the raw text, and we limit to the first 30 characters because otherwise it will become too long. And then we just like type ... So we check how that looks like, and how does it look like. Of course, well, if we have this singles text here, so this is maybe singles who go looking for other people on the web. If we go to this website, maybe that's a website wine.txt, then it says what a description of wine, right? So we have different web texts here, and this is their content. So then we have, if we have such text, so how do they differentiate from the Gutenberg corpus? Well, they are very informal. So the Gutenberg corpus is like very refined language because it's poetry or it's like prose. But in any case, it's like a fictional text that is highly artificial, highly refined. So there was one author spending a lot of time writing this text. And in contrast, this web text is very informal. So what are the special characteristics? So there's different terminology. So there are different words being used in web text versus poetry text. Of course, well, maybe people on the internet use slang. They make orthographic mistakes. They mistype. They use their local language, their sociolects, etc., etc. And there may also be grammatical differences. So the one difference is on the level of the words, and the other difference is maybe on the level of the grammar. Maybe it's less formal. Maybe there are grammatical errors because also there are not only native speakers make grammatical errors, also especially non-native speakers make them, right? So there may be grammar and vocabulary differences. And which corpus you choose, that of course, you could ask yourself, should I work with web text, or should I work with Project Gutenberg? And this, of course, depends on your research question or what you want to find out. So if you want to find out if you want to find out something about poetry, maybe how poetry has changed over the years, you will use the Gutenberg corpus. If you want to find out something about how informal text on the web is written, you'll of course use the web text. It all depends on your research question. And of course, you can also compare different text genres, right? How do they differ in the terms of the vocabulary that they use? And also you could do a grammatical investigation.
Okay, let me next talk about the Brown corpus. The Brown corpus was created in 1961 at Brown University. It has been the first million-word electronic corpus of English, so it has been one of the first large-scale text collections for English. It has been compiled from different genres, so it includes news text, reviews text, fiction text, adventure text, government documents, and government statements. And if you want to check the complete list of text, you can go to this website and check it here. Again, how do we access the Brown corpus? We import from NLTK corpus the Brown corpus. We can then check its categories. So I've said that the text in the Brown corpus have been classified for their different categories. I would also call these categories labels or classes because we can assign each text document in the corpus one class label, right? One class, one label, one category, one topic. These are often used synonymously in the machine learning and natural language processing community. Here you can check all the categories. Then the question here is, why should we care about categories? Well, that's why should we care? Because sometimes we want to analyze only text from a certain categories. For example, if we're humanities people, we're maybe more interested in science fiction, in romance, and we're maybe less interested in newspaper text. On the other hand, if we're politicians, maybe we're more interested in newspaper text or government text, right? So that's why we would care about those different classes. If you want to get all the words from a certain category, you can specify this by giving the category that you're interested in. You can also get the words that belong to a file or several files with certain IDs. So here you see the file IDs as before. And you can do the same for sentences, of course. So our next corpus that we check is the Reuters corpus, which is it's compared to the Brown corpus. It's more focused on one specific genres, namely news documents. It contains 10,788 news documents, which have 1.3 million words. It also has those categories, which, as I said, we call also topics or labels or classes. In this case, it's exactly 19 different topics. It also is grouped into train and test set. So we will learn the notion of train and test set later on in the lecture. Here I can already say that imagine we want to have a computer automatically label our documents into different categories or different classes. Then in modern machine learning or in modern natural language processing, we usually have two steps. In the first step, we train or learn our algorithm, that is called training. So we reserve a certain set of documents which give instances and illustrations and examples of documents with certain labels. So we show our computer, our algorithm, look here, this is an example of a document that has class label number 8. And then we hope that our computer will learn the characteristics of this class number 8. And then afterwards, if we have trained our algorithm, we can test it on a test set. So this is why this distinction is given here. So it's even from the start within NLTK, it's used as like a document classification data set. So you can really train new algorithms on that. If you want to access, we do as before from NLTK corpus, we import Reuters. We can check the file IDs. Now this time their names are given by whether they are train or test set and then their ID number. We can check the 19 different categories. So here are the 19 different categories. They have strange names, which are not immediately clear on first view. But in general, I think they just give the content of the document. So whether this document is about coconuts, whether it's about cotton, or whether it's about some sort of oil. If we compare the Brown versus the Reuters corpus, they have one distinguishing aspect from a machine learning community, namely the Brown corpus. In the Brown corpus, each document is assigned exactly one label, one class, one category, whereas in the Reuters corpus, one document can have multiple categories. So that we can say this document is both cotton oil, is both about cotton oil, and is also about copper, right? If you want to access the Reuters corpus, again, you can get all documents that have certain labels by typing dot categories, and or you type dot categories, you give a list of the file IDs. So you say file ID training 9865 and file ID training 980, and you can check which labels do these two file IDs have. You can get all file IDs that, for example, deal with the topic or label of barley. You will get them as a list. You can get for a certain file ID, you can get all the words again as before. In this case, we would limit it to the first 14 words. So you see the text here, and note that the first uppercase words are the document title, so the title of the document, because we don't have a telling name here. So the title is given as the first few words. We can also get the words that we can get all the words of all the documents that belong to certain categories. If we compare the structure of different corpora, we can classify them into certain
high-level characteristics given here. These high-level characteristics, in this case, we group them along 4 dimensions, namely isolated, categorized, overlapping, and temporal. And what we mean by this is isolated, that's a simple collection of text without any annotation. So you only have the corpora, but you have no class labels, for example, or no other types of annotations. When we have a categorized corpus, it means that the documents in the corpus are categorized along different classes, such as given in the Brown corpus or in the Reuters corpus. But then we still distinguish between categorized and overlapping, and this overlapping means that one document here, so this is one document, it can belong to multiple classes. So in this case, it would belong to 2 classes, to 2 categories, while in the Reuters corpus, each document only belongs to 1 class. So this is class number 1, class number 2, class number 3. Here it's not non-overlapping, here it's overlapping. We can also have temporal corpora, where we can check the language use over time. So, for example, the corpus of presidential speeches naturally has a temporal dimension because those speeches are across different centuries, right? So it goes back to the late 18th century up until the early 21st century, right? Because now we're like in 2020, so we all have all those presidential speeches. They have this temporal dimension. If you have such a temporal corpus, you can, for example, check how language changes over time, and language changes always changes over time. So we find that words acquire different meanings over time. One example being, so here are a few German examples, maybe of words that become outdated or that come into new existence. So the word Jach, I don't even know what that means. That seems to be a really outdated word. Schema, this is still in my passive vocabulary as a German native speaker, but I would not use that actively anymore. Whereas the word handy has newly come into the German list of vocabulary in the last like 20 to 30 years. So we have lexical changes over time. We also find that individual words change their meaning over time. For example, check the word gay, which like in the 17th, 18th century in English meant something like cheerful, happy, and nowadays means something like homosexual. So if you want to investigate a temporal change of language, you would best go with a temporal corpus. So here are the methods and the functionalities that we've seen in NLTK to get the file IDs for a corpus, to get the categories, the class labels, to get the raw text, to get the words and the sentences, and they have different arguments that you can specify. And you're happy to do so both in the practice class and in the homeworks and for your own self-study. And I really encourage you to do that, because only in this way, by doing it and by invoking those arguments, you can learn learn more and deepen your knowledge about NLTK and Python and what you can do with these corpora and on these corpora.